All right, happy Wednesday, halfway through the week, almost another week down, and much fewer school days left till summer vacation. So we started talking about solutions. Oh, real quick, I'm not sure if you were told, but just know that for the test, it seems the average wasn't too high. So for this test, we will be doing test corrections, but we will be doing those once everybody takes the test. So probably next week. I did take it out of the triad grade though, so it won't be in this triads grade, so that way it wouldn't mess up anything. All right, so we started talking about solutions. We're going to be talking about solutions and molarity. We talked about different types of solutions, right? So homogeneous and heterogeneous. And we also talked about solute and solvent, right? Solvent, you can think about it as solve it, what's dissolving the other thing. Usually it's whatever's in large quantities, and then solute is whatever's being dissolved. So if we go back to the example of sugar and water and sand and water, right? Water is a solvent. It typically is water. And then solute is whatever else is added. So like the sugar that is being dissolved. So today we're going to be talking about water, which is the common solvent. Okay. So if we think about, we're going to go back to molecular geometry here, in that unit where we talked about polar and nonpolar. So if we talk about water, so water is the common solvent. And not just in science, right? We see it in a lot of real life, per se, situations. So we have our water molecule. We have our oxygen. And then we have our hydrogens here. It's a bent shaped, just a little review there. Oh. Okay. Just a couple things that are important to note here. Our oxygen and hydrogen bonds are what kind of bonds? Do you remember? There's ionic and covalent. They're covalent bonds. I know it's been a while, right? But covalent bonds, remember, those are bonds between any elements that are next to each other in the periodic table. In this case, we know hydrogen's all the way to the left, but these are considered covalent bonds. Ionic bonds are those where you have, say, sodium and chloride together, so two opposite elements on opposite sides of the periodic table. And here, because if you look at your periodic table real quick, you look at your periodic table, oxygen, what kind of charge does oxygen have? Negative. So remember when we drew these, we had to draw those on the molecules. And then hydrogen, what charge does hydrogen have? Positive. Yep. So because we have the negative here, positive and positive, and that would be considered an unequal distribution of charges, right? Because we have one negative and two positives. This is a polar molecule. So polar means there's different numbers of charges for negative and positive. Non-polar means there's an equal distribution of charges. And because it's a polar molecule, this allows water to dissolve other compounds. Okay. So whenever we have a solution where water is the solvent That is an aqueous solution. So aqueous solution in which water is the dissolving medium. Or in other words, the solvent. Okay. So whenever we have a solution that we say it is hydrated, right, or we're talking about hydration just in general, here hydrogen is attracted to negatively charged elements, which are anions, and our oxygen is attracted to, the opposite, positively charged elements, which are cations. And just like if you were to get hydrated, right, if you were trying to hydrate, especially if you're in sports, right, you don't necessarily just drink water. Why? Because water doesn't really do much. You need to add something else to your water, right? So if you have electrolytes, or sometimes just adding a pinch of salt, specifically more cleaner like sea salt or Himalayan salt, it helps you hydrate faster. So here I forgot to add of an ionic solid, which is a salt. Remember, and you don't have to copy this down, but remember, a salt or an ion, right, is something that is positive and something that's negative that comes together. So for example, like sodium chloride, right, table salt. So basically, to sum up hydration, it is when ionic substances or salts dissolve in water. Oh, that looks ugly. And separates into cations and anions. Okay, so remember, cations positive, anions negative. So for example, if we were to grab NH4, NO3, ammonium nitrate, which is a solid, and we were to dissolve it in water, which is a liquid, right? What two things would we get? Remember, this solid is going to separate into a cation and anion. So if we look at our periodic table on the back side, on our polyatomic ions, we have NH4+, which is going to be aqueous solution, right, because we dissolved it in water. And then we're going to have NO3, which is going to be a negative, right, nitrate, and it's also going to be aqueous. Okay, so just to kind of give you a glimpse or example of what that is actually talking about. So let's talk about electrolytes. So right now we talked about solutions. We're talking about water specifically, about how it acts as a common solvent. And then we're going to talk about how we view water or aqueous solutions in terms of strong and weak electrolytes.